This is an interview with Chris Deot, one of the few Quadruple Kaggle Grandmaster and a senior data scientist at Nvidia. Chris' passion is mathematics. Before Nvidia, he did a PhD in computational science and mathematics. Then, he was a math researcher and lecturer at the University of California, San Diego, until Nvidia found him on Kaggle. This interview is also in partnership with Nvidia, and more specifically their GTC event coming, where by participating and sending me a screenshot of one of the events you are attending, you may be the winner of an RTX 4080. Just attend the free event, send me a screenshot, and you could win. I hope you enjoy this interview.
Thanks a lot for having me on the show, Louis. So my academics background is mainly in mathematics. I would say. So I have a BA in mathematics, then I have an MA in applied math, and then I got a PhD in applied math with a specialization in computational science. So you can see my first and foremost passion is mathematics.
And how did you get into Nvidia or data science from the mathematics background?
Yeah, so after getting my degrees, I worked in academia as a researcher and lecturer, and the life of academia, is pretty flexible. You have a lot of time to do your own research, read, write, and stuff. So during that time, I started looking into data science, and then started learning it on my own. And then I found that I had a big passion for it. So then I started playing around in Kaggle, and then eventually got noticed by Nvidia, and then from there I transitioned from academia into a data science role.
Yeah, I'm excited to dive into all those parts, but for start, could you explain what is a data scientist to you, or at least what is your role as a data scientist?
Yeah, it's an interesting question. I know everybody has a different opinion. I feel that data science is the three things: data analytics, machine learning, and deep learning. And I think ultimately they're all about finding patterns in data.
Yeah, that definitely makes sense, which also led you to Kaggle. But beforehand, I just wanted to cover a bit more the data science space, and especially what is in your mind required to become a data scientist. Do you think it is mainly a role for academia because it's a lot of like statistical knowledge, a lot of math, and a lot of theory? So do you think a PhD or a master's is necessary to get such a role?
Absolutely not. So I've met a huge variety of data science. I think data science encompasses such a variety of skill sets that I've seen people with a whole variety of backgrounds, right? I mean, if you dive more into analyzing the data and making charts and presenting it, I see people with backgrounds in English and language and stuff. If you dive more into technically working with the numbers and the models, I've seen people with math and science. So I've seen people from all walks of life, and I think that at the end of the day, it comes down to basically, as I said, finding patterns in data. And I think whatever your background is, there's a place for you in data science.
What is your place like at Nvidia? What you are doing as a data scientist?
Yeah, so I'm on a special team called KGMon, which are the Kaggle Grandmasters of Nvidia. And as such, we do a wide range of tasks. So maybe in other fields, a data scientist might work on more of a specific thing, kind of over and over. Maybe they're in charge of prepping data, or they're in charge of building a model. But in our role, we kind of wear all the hats. So often I'm doing, and then we split our time between Kaggle and internal projects. And I would say often, I'm analyzing data. I work a lot with Jupyter notebooks. So I basically work on a lot of data sets. I help the company, find patterns, what have you. I make presentations, make slides, I do that. We're also trained tons of models. Obviously, on Kaggle, we make models. And then internally, all businesses need models. So a lot of my time is doing experiments. You always want to make the models more accurate. So that's kind of the core engineering stuff. But then I also do some other things like I read research papers to stay up on the latest stuff. And then also my coworkers and I will frequently give workshops. We'll be doing a little training workshop upcoming at the Nvidia's GTC coming up, and then we've done other little mini workshops here, or did presentations, or write blogs, or share some material in Kaggle stuff. So it's kind of a combination of sort of teaching and research, which I like, and then what I've passed in, and then it's also, you know, the engineering stuff about analyzing the data, making some plots, and then also making accurate models.
I'd love to dive into the differences, and also how Kaggle and Nvidia, your work at Nvidia and Kaggle, can complement each other, or just the difference in between the two. But first, maybe we can just start by, for the people that don't know anything about it, maybe explaining what is Kaggle, and also what is a Grandmaster at Kaggle.
Yeah, sure. So probably the first word to describe Kaggle is addictive. I know I know my coworkers would agree with me. It's just really exciting. But for anybody who's a data scientist, it has everything you want there. So, you know, you can access data sets, you can access data sets and explore interesting data sets. There's forums where you could talk with other data scientists. So I don't know if I said this. So it's an online website, an online community, right? So you go there, you can talk to other data scientists in forums. You get access to Jupyter notebooks. They have free compute, so you can run some code. Then you could also share the code. And then finally, I think, which is the most maybe exciting and addictive, is they hold competitions. So a variety of things where for a few months, there's a leaderboard, you're building a model, you have to predict unseen data, and then you get a score, and then you're ranked against other competitors. And that's really exciting.
So I assume the most addictive part is if you like competition, or if you like competing.
I think so. I mean, I would actually even say, you know, some of the other things were addictive to me at first. So in my beginning, actually, I spent more of my time in the forums and just talk with data science, because, you know, it's a new field. Yeah. So, but actually, maybe now it's become, you know, maybe mainstream like 5 years. But when I started like 3 years ago, I didn't have anybody to talk with. Even when I walked around the university, there's statisticians, but nobody was doing data science. So at first, it's just exciting, right, to find a group of people who are passionate about the same thing. So I would even just say the community is addictive, the sharing of ideas, having people to talk to. So that's what sucked me in at first. But then, yeah, at this point, the competitions are extremely addictive, right? Because yeah, you might wake up in the middle of the night with an idea and say, oh, here's a great idea. Then you add it to your model, it boosts your score, you submit it, and then you see yourself jump on a leaderboard, and you know, and then 2 days later, someone jumps over you. So the whole competitive thing that is also highly addictive.
Yeah, and as you said, it's super easy to get into it and start right away. And I believe you are also practicing really useful skills. But that's also a question I wanted to ask you, since you have much more experience than I have with Kaggle. And so my question was basically, do you think doing Kaggle competitions is a good way of improving your resume and just building good experience for the industry if you want to work in the industry?
Absolutely. Yes to both of your questions. So first off, I think everything you do and learn at Kaggle is immediately applicable to work. All the skills you learn, you use at work. Later, if we dive into it, there's like some additional things you might do at work which you don't see at Kaggle. But everything you learn at Kaggle applies. As for resume boosting, I think it absolutely helps, because I think when you apply to these companies, when a company is about to, you know, invest in a new employee, they'd love to know if an employee can actually do the work. I mean, have they done the work? And Kaggle is a very concrete example. If you posted anything, if you participate in a competition, it's a concrete example of, oh, look, this guy has written code. I can look at his code. Look, this guy has been in a competition. Here is his results. I remember when I went on some technical interviews before Nvidia, they would often ask me, you know, what projects, like describe a previous project. So it wasn't even, they don't even really care what you had done. They just want to know you've done something. Can you talk about it? You know, what software did you use? What were your approaches? So Kaggle gives people a very concrete, you know, examples they've done the work, and I think employers really like that, and it gets you in the door and moves you further along. I think of the interviews.
Yeah, I definitely agree, and I know that a lot of because we also have I also created a community on Discord called Learn AI Together for the same reason as you were using Kaggle's forum just to chat with people in AI also 3 years ago, and through this community we are also helping people getting started in the field, and so one of the like we have a practice section where we basically try to give tips on how to practice and just get better, and basically I try to share that you need to create something, like share something online, or at least do Kaggle competitions. That's what I defend. Like you need to, in my opinion, the best way to learn is to learn by doing something, just because it motivates you and you also end up having something online.
Absolutely. And I have a fun example actually. I remember when I had just graduated from my PhD and I was at a job fair, and I was going with one of my buddies. He was walking around with me, and we were walking from table to table, and there's all the big companies, all the big tech companies, and we were talking with some recruiters and filling applications. And my friend, I always remember this, he designed a little cell phone app. It was a little hangman game. And every recruiter he would show it to, he's like, look at this app I'm working on. And he'd kind of play it. Man, the recruiters loved him. He got out of all of our friends, he got the most. He was accepted to the most interviews. He connected with the most recruiters because, like you just said, they love to know that you've done a project.
Yeah.
It shows your skills and it shows your passion.
Yeah, definitely. I have like the same anecdote where I think it was last year at CVPR. One of my friend had built his own. I don't remember how you say that in English, but his card, like a card where there's your name and your
Oh,
information,
business card.
business card. But he had like some kind of NFC and something that he could just tap on the phone of people, and people will like it will open his LinkedIn and
Ah,
everything. But he also built like hundreds of cards like those himself, and just like made all the material and everything himself with his like in his kitchen and everything. And so he had a few hundreds of cards, and he just gave it away to a lot of people. And he yeah like he was basically the star of CVPR. Like everybody loved his card, and it was in the end it's super simple, but he made it, he put in the work, and it's just what puts you apart, like just having something that you can show.
yep, I
So
agree.
so yeah, I basically think that Kaggle basically allows you to do that relatively easily, because you just have to create an account and you can join a competition right away. But
Yep.
yeah, one of the I'm not sure if that's a downside, but one of the thing that people are skeptical about is that a lot of people say that it's kind of too easy, or like not like the real world, and it basically relies on automated processes and a lot of stuff that you don't do in the real world. And so I wanted to get your opinion on that. If really you said that the skills are directly applicable, but I wonder if there is there some only specific to Kaggle stuff that isn't really useful, but this is what works on Kaggle and doesn't work in the real world.
Not really. I mean, I think everything that we do on Kaggle, we do in the real world. A lot of people will disagree with me because they'll say stuff like, "Oh, on Kaggle, a lot of times, you know, you you're doing EDA on some of the test data, but in the real life, we wouldn't have access to that test data." But the thing is, I can always contrive some example in real life where we've trained a model on some data, maybe some kind of medical images, and then maybe for the next month, I get my hands on some new images. I don't have the labels, but at least I see the image. Like some people say you'll never see any test images. Well, here I trained the model on a bunch of images from the last 3 months, and I have labels. And now for the next month, I've got some unlabeled images. And then I could use them. So everything I think you do on Kaggle you can find an example where it works. Back to address what you were saying earlier is it's not given. If you're highly successful on Kaggle, maybe there are some things that additional things you'll need to do in the workplace. So maybe it's not a given that just because you're doing well on Kaggle, you do. For example, in real life, a lot of times the data is messier, right? So in real life, you're required more to collect your own data and then go through the process of cleaning it. There's always weird stuff. If a text column, you have some weird characters you might have to remove, et cetera, et cetera. So yeah, Kaggle does all that, so we don't have that. Also in real life, a lot of times, if you're working with a client, they just describe what they want. They don't give you a metric. They say, we want a model which, helps us to, predict the diagnosis from a medical image. But they don't say we want AUC or we want, accuracy or this. So, if the diagnosis is 1 out of 10,000 times, then you would have to know not to use the accuracy metric. You would need to know to use AUC. Yeah. So you need to figure out what's relevant and what you should train your model with. Once again, Kaggle just sort of tells you. So in real life, the data's messier. You need to actually understand the problem enough to figure out which metrics to use. And that involves how to design the model. There could be other issues with production. So there's a lot of more things that sort of come in real life, but absolutely the basic skills of setting up a validation, the different models we use, how you actually write the code, use the libraries, that's all one and the same.
And since you said that, like the major difference is that basically Kaggle already has the preprocessed data and also the metrics. Are most competitions similar to one another? Or like, is there different challenges depending on the competition?
Yeah, so all the competitions sort of fit into that template, which is, they provide data, you're building a model, you're evaluated on the metrics. So you could say that they all follow that common template. But I would say that they all, once you're in the field, they all feel very different. In the same way that, basketball, soccer, and tennis, they're all a sport that uses a ball. There's people. I mean, you're right, but they're very different. So, so the competitions, I would say, fall into some big categories. You have NLP, natural language processing competitions. You got computer vision competitions, both image classification or object detection. You've got tabular data. You've got time series. So you have and some are involving physics and science-based things where domain knowledge can help. Maybe using equations can help. Other things are just more purely tapped. So I would say that the data comes in tons of different varieties and different domains, and they require a huge variety of models. They're different models which need to be used, and then the metrics are different. So if you think about all the flavor of all that, then I would say it radically makes a difference, because I think in the field of data scientists, you have specialists. So someone who actually specializes in computer science, they may not know how to do tabular data. So really, actually, I would say that the Kaggle competitions actually encompass a range much wider than what a single data scientist in the real world would do. Yeah. People on my team, we're kind of versed in all of it. But I would say, a typical data science would probably just be versed in maybe one of the domains.
And so Kaggle will allow you to be more of a generalist?
Yeah, I mean, if that's your interest, basically, I would say the opportunity is there, but it doesn't necessarily encourage people in that direction. There's many Kagglers who I noticed, they only participate in one type of competition. Okay. You'll see many Kagglers only do computer vision. Many Kagglers only come out when we have tabular data. So, but the opportunity is there. If you want to learn more things, then it's an amazing playground where there's opportunities to, learn all the different types of building models.
And how, if, for example, someone wants to get into Kaggle and start and maybe win a competition, how would you teach this person to start and like give any tips or tricks to at least like have some chances of winning?
Yeah, so I've been asked this often. So I have sort of what I always say about how do you get started. I think the only obstacle, and here's me making my quote of the day. I think the only obstacle to Kaggle is thinking there is an obstacle. Now that paradox means people are always saying, how do I get started? there's nothing to it. You just hit the join button and you get started, right? There's really, it's kind of, and I was the same way. It took me months to join my first comp, but really when it comes down to it, you hit join. And then when you're in, it is a little intimidating. You see all these people talking about stuff you don't know about, but you just make baby steps. Your first goal is to just submit a submission file which has all zeros. And then your name pops up on the leaderboard, right? That's step one. Then you make it your goal for the whole week. You're just going to make it better somehow. You're going to put 1-1, like you're going to put the number 1 in place of one of the zeros. Use a model, use whatever. And then your score is a little better, right? So you just kind of, you keep evolving it. And actually, once you do that and take a few baby steps, like all of life, you build confidence and you realize, wow, this isn't that bad. And then actually, you'd be surprised, both myself and others will say this, you know, by a couple of weeks in, yeah, you're training models, and you'll see yourself in, you know, in a decent position.
So you mentioned that on your end, you well, tell me if I'm wrong, but you enjoyed entering into competitions of different fields like NLP, computer vision, tabular data, and everything. You do a bit of everything.
Yeah, I do. Yeah, I do. Because for me, Kaggle is, I mean, people have maybe different motivations, but for me, you know, when I enter a competition, I would say half my motivation is learning and half is, you know, competing or winning. For the people that, you know, only are there to kind of compete, then I think some of those may not branch out as much. But yeah, for me, a lot of times I'll join a new field I've never worked with. So, you know, I built some of my first types of models specifically on Kaggle. I remember, you know, I built my first neural network. Well, no, I guess I made some of them work out, but maybe okay. My first gradient boosted trees was on Kaggle. I was in a competition. There was a tabular data comp, and then I hop in, and then, you know, I built my first one. So a lot of times, or there was a comp which my first time working with audio. I just saw the comp and I said, wow, I've never worked with audio. Let's join this. So for me, I kind of do use the different types as a way to learn. And then, as I said, when you're in the comp and you see your name on the leaderboard, it's even motivation. It's like, okay, now I have reason to read that book or read that paper because I want to see my name go up. So it motivates you to kind of figure out how stuff works.
Yeah, so it's also a great way to stay up to date with pretty much all fields, just because you want to get better and actually win the competition.
Oh yeah, certainly. Well, yeah, it's kind of neat like that, and it's particularly interesting. Me coming from academic background, because in academia, or I guess in any area of life, well, maybe in particular in academia, sometimes people just do research for the sake of research. They just read some stuff, or just in school, you're just kind of learning, but you don't necessarily have a goal to apply it. You're just kind of learning and learning. But it's cool that Kaggle actually, you know, adds this additional thing to the learning process, which is if you successfully learn this, you're going to see, you know, your rank increase on the leaderboard. So it's something that, you know, schools and research don't always have, but it's like you get immediate gratification. Okay, if I read through this chapter in this book and I take the time to understand it, I will see a result. I'll be able to apply it, and then I can see my name go up. So it's kind of neat how it gives you an immediate application, and then sort of so it gives you potentially more motivation to learn everything.
Yeah, definitely. It's just like having having your own startup or something. Like the work you put in is directly correlated with the output and what you gain from it. So it's like much more motivating.
Right. Because I've seen, you know, I've seen some friends of mine, you know, over the years, I have some friends who say they want to learn data science and they open a book and they read it, but they're not on Kaggle and they just read it for a few weeks and they're kind of excited. But then then I've seen some of them just kind of, you know, get distracted by other things in life. So but Kaggle, you know, by joining the comp and you kind of commit yourself in a sense, and then if you're sort of competitive in nature, that, you know, you start, and then it motivates you to kind of stay with whatever you're learning so that you could see results.
And yeah, so continuing on Kaggle, pretty much my last question directly related to Kaggle is just coming back to the Grandmaster. So could you go over to the people that don't know about this? What is a Kaggle Grandmaster and what does it mean to have this 4 times?
So Kaggle allows you to win medals, awards, which can which you can then acquire titles, but they actually there's four general categories. So there's a notebook section when you share code. There's a discussion section when you uh, discuss stuff in the forums. There's a data sets section when you share data sets, and then there's a competition section when you compete in competitions. So in each one of these categories, if you do well, then you earn medals, gold, silver, and bronze. And then each one has a requirement. There's a whole tier system. So I think you start out maybe as a novice or something, and then you become an expert, and then you become a master. So as you acquire more medals, each one has a criteria. If you have this many medals, then you become an expert. Then you achieve master, and then the highest achievement in each of the four categories is grandmaster. So I've been on Kaggle now for about 4 years, and I've acquired a grandmaster in all four categories. And to give you some specifics, some consider the most prestigious to be the competition grandmaster. And then specifically to achieve a grandmaster, you need to acquire 5 gold medals, and one of them you need to have acquired by yourself without teammates. So, and a gold medal in a competition, so an average competition has about 2,000 entries, and a gold medal would be roughly maybe the top 15 positions. So you could kind of see to become a competition grandmaster, you've got to compete against 2,000, 5 times. You have to compete against 2,000 people around the world. And these people are, experts in their field. You have a lot of companies. These are mostly data scientists who do this for a living. So very strong competition. And you have to place in the top 15. Now you can team up for 4 of those medals, and that's good. You can collaborate, work with others. But then for one of those medals, it's a requirement. You need to, get it by yourself. And then once you get it, then your profile indicates that you're a competition grandmaster, and it's good. I mean, it's a really prestigious title, and it's recognized. I've met data scientists at conference or just out and about who know about Kaggle, and then they hear you're a grandmaster, and they're really impressed. So it's and companies and everything, people hold these titles in very high esteem. Kaggle has, I think, 6 million users. So it's in this whole user base. I'm one of only 4 people. I think. Wow. I may have been the second to obtain it. So, obviously over time, more people will obtain it, but maybe I was the second. Yeah, I was quite excited about that.
Is there
a lot of, I was gonna say one more thing. I think a lot of more people could obtain it, but I think some people just sort of focus on one category and they're happy with that.
Yeah.
But, I like teaching. So, I spent a lot of time sharing notebooks and sharing discussions, and that allowed me to, you have to do a lot of sharing, and then to get the medals, people have to like it. You have to get a lot of likes, and then you acquire medals there. So discussions grandmaster, I think I needed to make posts with 50 gold medals, I forget, and some other medals. So you have to make a lot of liked posts. But I enjoyed doing that.
Was there one of the categories that was hardest for you, or that you didn't enjoy as much?
So I think so I enjoyed all of them. The most difficult probably was competitions, because when I joined the website in my first year, I entered some competitions, but I shared a lot. So I would find a secret and be very excited. I would analyze the data and find, oh my gosh, this particular feature, if you use it in this way, it boosts your score. And then I'd be excited, and I'd post that in the forum. And then I was up here, and then all the teams would jump above me, and I would keep doing that. So in my first year, is when I acquired the Grandmaster in both discussion and notebook. But at that time, I think I only got 1 gold medal in competitions. And a lot of people told me, if I wasn't sharing all my secrets, I actually would have been a competition Grandmaster in the first year. So it was difficult for me, because then in the second year, I had to make a conscious effort to, I still share all the time, but instead of maybe revealing a secret, it would be more how-to guides. This is how to build your model. This is how this works. But I didn't necessarily give away secret details about the data. So I had to kind of hold my tongue, so to speak. And then in the second year, I was able to acquire the competition Grandmaster. But I think maybe holding my tongue was difficult for me, because really, I don't know if I'm super competitive. Well, I am competitive by nature, but I think I enjoy sharing more. So when I find an insight or something, I actually would prefer to just share it with everybody. But I realize that to win in comps, you have to kind of keep some of this to yourself.
But it's also a sort of winning, just by sharing something that the others didn't know. Like you are the one that found this, and that that taught people. So it's also a big win.
Absolutely, and actually, Kagglers are great people. Like they're very friendly and appreciative, and I love that about the community because you're right. I'll share, and then even if I don't win a gold, people they'll thank me, and then they'll say how they were rooting for me, and then I was the big win. Basically, they show their appreciation, and you really feel that whether you got the medal or not, people really do appreciate if you're sharing.
Hey guys, I'm quickly interrupting this video. I have some cool t-shirts, sweatshirts, and even a jacket that you can see in this video. I hope you like the different designs and feel free to buy it to support the channel, or not buy it, it's completely fine. Just leaving a like and commenting is all I need. Did those Grandmaster titles help you to get into Nvidia, or was it more your work at Kaggle, or the academics and everything you did outside of Kaggle, or both was great? Like what was the main factor for either Nvidia to find you or just to hire you?
Yeah, so Nvidia is a unique job in that I'm part of a team called the Kaggle Grandmasters of Nvidia. So it was actually a requirement to be a competition Kaggle Grandmaster, to be accepted for the position. So in that sense, Kaggle was crucial. But I've also gotten, before Nvidia and over the years, I actually get a lot of solicitations from other companies who want to interview me, simply based off of just seeing a result of a competition or seeing a popular notebook. So in general, I would say all companies are sort of looking at Kaggle. They're using it to kind of see, what the talent pool is. And then, as I said, Nvidia was a little unique because it was sort of what the job was about, but it helped. And even when I went on my interviews, I could tell they had reviewed my work because I had publicized a bunch of my code and discussions, and I could tell that they were familiar with it. So I think it even helped them, there was still, Nvidia, even though I was a grandmaster, there was still an interview process like every company, questions, etc. But I could tell that they had reviewed my work, and I could tell that that was already contributing to my case. They saw, oh, he knows how to do this, he knows how to do this.
How was the interview process like? If they pretty much already knew you by heart, like they already knew how you worked and what you knew, so what was the interview process like?
Yeah, so I would say it's similar to other technical companies. So in my past, I've interviewed with other technical companies. There's, it starts out with a few phone calls with HR, review your background, your resume, stuff like this, your personality, and then if you do well, and then if you move forward past the initial screening process, there is a technical part where you'll meet with, in the course of one day, you have 6 45-minute sessions with actual engineers, and it's all a technical conversation. They feel you out, how do you do this? How do you do this? What's the code for this? So there is sort of a technical aspect. As I said, they were familiar with my code, so it probably was a little bit more of just kind of confirming that maybe, that I knew what I was talking about, kind of thing. But you have to demonstrate through a conversation, some questions that you understand the technical aspect, and you know how to build and apply models. So there was sort of the technical thing, which is what it's like at other companies. You have your series of technical interviews with engineers, and then after that, then you wait a few days. You say, oh, do they like me? Do they like me? And then a few days later, or I forget the actual timeline, but basically after that, maybe some more phone calls. But then if they like you, then they offer you the job.
And that's like the usual for 6 interviews with engineers and professionals in the field?
I think so. So I applied to, maybe in my whole lifetime, I've probably gone on, well, I mean, a handful, maybe about 6 technical interviews with engineering, for positions in the software/data science field, and they all seem to follow that template, which is there's, after a bunch of initial phone calls and screening, there's just like an initial screening process. Once you get through that, every one of the companies, you spend a full day, and actually all of them, they're all different, big different tech companies, but it was all 6 45-minute sessions, and it was an actual engineer who worked at the company, and they would ask you to either write code or answer technical questions and stuff like that.
Oh wow, that's hard.
It is hard, and when I did it, and I talked to friends, anybody that's applying into a technical field, as I said, programming, data science, etc. You actually know a lot of them will spend time like studying beforehand,
Yeah.
just like you do in school for tests. So you practice writing some code, you practice yeah, I mean you practice whatever's relevant for that position, and it's helpful.
Did you practice, or was Kaggle enough? Like, how did you prepare for these interviews?
So Nvidia was not my first interview. Basically I had been out of, so I had got my, let's see the timeline. So I got my PhD in 2014, and I think I started working for Nvidia in 2020. So you can see I was out 7 years. So during that 7 years, I had been on interviews here and there. I mean, I was in academia the whole time, but occasionally I applied to an industry job. But I never found anything that pulled me out. I never found anything that was interesting enough that pulled me out. Anyway, over that time, so in my early interviews with technical companies, I did spend some weeks reading books, studying algorithms, practicing coding really fast. My friends and I, we'd stand at whiteboards. I did the whole, I mean, this is what people do. You practice to be comfortable with it. And then companies would fly you out to their headquarters and then put you in front of a whiteboard and do that. So I had done a couple of years of that. So by the time I was interviewing with Nvidia, I had already I was already familiar with the process, and I had been doing data science, day in, day out. I've been caggling and stuff. So I felt my skills were up to date.
Yeah.
So I didn't particularly prepare had I had done, previously.
And how can, like, as you mentioned, you are one of the few that is a quadruple grandmaster, so you know a lot about data science and just the different modalities and everything related to data science. So how could they assess your skills if there are so few people that can do what you are doing?
Well, yeah, that's the reason that the technical interviews have six
Yeah.
interviews, because they literally, you actually meet with a different specialist in a different thing. That's the thing. So you'll meet with someone who's specialist. I mean, yeah. So I met with one guy at Nvidia, and he works with tabular data. So he asked me all about how do I process tabular data, et cetera, et cetera. And then I meet with another guy who his background is deep learning. He trains neural networks. So that's why a company has you meet with a bunch of different engineers often. The different engineers can sort of have different specialties to ask you questions in that specialty.
Yeah, so also it's also not a big deal if you, for example, if someone goes into the process and completely fails his first technical interview, it's not over. I assume if you fail one, or like if you are not as good as you think in the first one, you may as well just be really good in the other interviews because it's different fields.
Well, yeah, and actually, so working at a college, I would actually consult some students about applying to jobs, and over the years, I've given some advice. So, as for interviews, and what I've learned even personally with my own experience, it actually is, I didn't know this at first, but it's not actually about necessarily getting all the questions correct. So this is important to know. So I give sort of two recommendations to people. First of all, interviewing is a process, just like anything, that you have to learn to get better at, because you could be nervous, you could whatever. So actually, I recommend, if you're applying to jobs, apply at first to as many jobs as you can. And actually, your first interviews, pick the companies you're least interested in. So just go out and find some jobs that you're not super interested in, and then go into their office and do the interview.
Yeah.
When I went out and did my 6 interviews, I actually got offers from the final 3 companies and not the first 3 companies, because what I just said, I learned how the process works. And by the final interviews, I learned it wasn't about getting the questions right. In the early interviews, I'm nervous, I'm writing it. If I got to a mistake, I might be like, oh no, I can't figure this out. In the later interviews, if you have trouble, you can actually turn to the interviewer and say, this is what I'm trying to do. Could you give me a suggestion? They like that. They love that. They're like, oh yeah, you're thinking of, you want to use the function, num to nan. And then you're like, oh, thank you. And you write it. So you actually learn that you don't get so nervous. They just want to kind of see how you think. Just talk aloud. Okay, this is what I'm thinking here. I'm going to try to take this data, which is 3-dimensional. I'm going to try to rearrange the array so it's 2-dimensional. This is what I'm thinking. And then here's my code. Okay, it looks like it's working. If you're stuck somewhere, you can ask them a question. So I learned it wasn't about like a school test where no one could help you and
Yeah.
it's right or wrong. It was more they just wanted to see how you think, and you kind of learn that over time. So I tell people, practice, go on lots of interviews, and then just don't be nervous and just tell them aloud what you're thinking and just be relaxed and then ask them if you need some help. And actually, those are the jobs that offer me the job, right?
And yeah, speaking of work and your Nvidia, could you a bit describe what you are doing at Nvidia? I know we already talked a bit about that, but what's could you maybe more in the day-to-day life, like what you are doing in your regular days at Nvidia?
Yeah, sure. Yeah, so as I mentioned, I would say that about half my time is spent on Kaggle, and then half my time is spent in internal projects, and all of it ultimately helps NVIDIA. So when my coworkers and I are working on Kaggle, we're trying to product test. NVIDIA, has a lot of open source frameworks. So a lot of times we product test a lot of new frameworks. We utilize different things, and then after the competition finishes, we can meet with different product teams and give them our feedback, and we work together with them to develop the products. So that's kind of how the whole Kaggle thing works. But then half my time is also internal projects. So NVIDIA themselves, they have data which they need analyzed. They have models which they need built to do various things. And NVIDIA has partners because NVIDIA is giving out free software and the partners are using the software. So often we'll meet with partners and we'll actually look at their models and actually help them use the stuff to build better models, help them analyze data. So those are all the different hats I wear.
So you are basically like your addiction is being paid. Like you are being paid to just continue on your addiction and just do what you like to do.
Yeah, it's certainly a dream job. I mean, we all basically it really is. I'm blessed to have been offered this job. I absolutely love it. You can tell I love Kaggle. And actually, when I'm not working on Kaggle, I would say all of my internal projects with NVIDIA, as I mentioned, they're very much like Kaggle because I think maybe a typical data science might work on, maybe it might stay on, one project for a very long time. But our team, the KGMon, we're kind of like consultants. So we'll move on to a project and, it might be, and so just like Kaggle, we'll have to kind of learn the details. And then usually every project involves building a model or consulting somebody on how they built a model. So it's just like Kaggle. So basically there's some data set. And then we do experiments to improve the model, and we share with whoever it is, our findings. So even when I'm not on Kaggle, and then I repeat this process. So I do that for a few weeks, maybe with one NVIDIA group or partner, and then I might move on to something else. So it's kind of like it's very similar to the Kaggle competition format, which is ultimately at the end of the day, people want models and they want accurate models, and we just kind of repeat this process over and over, helping people analyze their data and build accurate models.
And could you enter a bit into the details of one particular recent project or just a project that you worked on, just so people know like what is the challenge and what is the task and what do you have to do a bit more specifically to one example?
Yeah, yes, certainly. So recently I've been doing a lot of stuff in the recommender system space. And actually I've done it both. Some coworkers and I, we recently actually just finished participating in a recommender system competition on Kaggle, and we won third place and won $5,000. We're super excited. Whenever we win, we'll end up donating the money, but super excited about that result. And then, similarly, just kind of before this, I was working with an NVIDIA partner, and once again, we were working, a bunch of my coworkers plus the Merlin team, which is another team at NVIDIA that works specifically in recommender systems. We collaborated and we helped one of our partners build a better recommender system. And so in all these, so whenever we're building recommender system problem models, what that involves is very large data sets, because what a recommender system is basically given a user, you ultimately need to suggest items. And it's usually the problem is usually stated in predict. It sometimes says, here's a user, can you predict what they buy? But that's actually the same thing as recommendations, because when you're on Netflix or Amazon and it says, you might be interested in this movie, or you might be interested in purchasing these sneakers, they're actually predicting what you're going to buy. They recommend to you what they think you're going to buy. Yeah. So the process of predicting a person's behavior and recommending a person are the one and the same thing. And so you have these huge data sets, which oftentimes have millions of users. And then for each user, you have maybe 100 possible items you're considering recommending to them, or I would say 1,000. Or sorry, let me take a step back. First, you have to analyze the history data. So you have 1 million users, and for each user, you have about 1,000 history events of maybe what they had done previously. So already 1 million times 1,000, that's 1 billion rows right there. And then for each row, there's all, columns of all this information, timestamps, what the item was, et cetera, et cetera. So you can see these data sets quickly become very large, gigabytes, terabytes, and et cetera. And then you have to process all this information to understand, user preferences, to understand characteristics of all the items. And then ultimately, given a new user in the future, you have to predict some items. You can see it's so a recommender system is specifically a tabular data problem. You have a data frame and very, very large data. And then the final prediction is, given a user, can you name a list of items that you think they might purchase, which will then recommend to them.
And how do you deal with these very large data sets?
Yeah, so this was a fun story because when I first joined, to deal with these, I end up having to use GPU. So Nvidia obviously makes GPU. I'm not actually not being biased here. If you have a data set with 1 billion rows and you want to process it in any way, you have to use GPU if you want to do it in a timely fashion. And there was a funny aha moment because when I first joined Nvidia and I quickly jumped on one of these projects, I was actually doing it in pandas. And I remember I had written a bunch of code and somebody said, hey, do you have the parquet ready? And I said, what are you talking about? I just started running my code. So I would write the code and I'd run it overnight. I'd go to bed, I'd run it overnight, and I'd have the parquet the next morning. It literally took my pipeline 24 hours. I was using pandas on the CPU. And the guy's like, what? And then basically, my coworkers and the company, I started learning about rapids, and specifically QDF and Dask QDF. And it does all the same things pandas does. So, it can take a whole column and find the column's mean or group by a bunch of users and find the, then compute the average timestamp, all these computational things you need to do to say, produce new columns. All the exact same code, it runs with Rapids QDF on GPU. So I actually took my exact same code and I just replaced pandas with QDF and I hit run. And I did it late at night because I figured I figured, okay, it's going to be another overnight thing. And then when I'm getting ready for bed, 20 minutes later, my computer beeps, it's done. So it was a huge aha moment for me. Whereas something my whole life, it was just a given that these processes take a long time. That's just what you do. You're processing data, you expect to wait a long time. And then my very first time using the software, it literally did the same thing in 20 minutes. Which is like 100 times speed up. It was just, I just remember it so vividly today. It was I call it an aha moment, just how fast GPUs are. So now, whenever I have to work with these huge data sets and process a bunch of rows and columns, I always use GPU. And now, now I don't have the patience anymore. I can't wait 24 hours if I were to need something done.
And are you using do you have an actual machine or are you connected to some servers? How does it work at Nvidia? Because you mentioned that you continued using your CPU even at Nvidia, so I assume you were running this off of your own machine?
Yeah. So I mean, I have lots of stuff, right? Yeah. So I mean, at home I've got some computers. Of course, work gives you a work laptop, and then there's and then also Nvidia has a lot of cloud compute. So I have actually a lot of resources at my disposal. I have some systems on site, and then I do a lot of stuff in the cloud. So, but I always sit at my laptop. So actually, it doesn't really matter to me, even if I'm running, even if I'm using my desktop across my room, I'm actually sitting at my laptop, and then I shoot the code over, or I'm logged into my desktop and I'm say running code there. So for me, it never even matters where the code's running. Sometimes I'm in the cloud, sometimes I'm using a desktop across the room, but I'm always sitting at my laptop and I'm always looking at, a Jupyter notebook inside my web browser, and then the code's running, who knows where the code's really running.
And is this something that blocked you before NVIDIA? Like, for example, I know that a lot of people want to do Kaggle competitions and they want to learn and like practice AI related code. And oftentimes, for example, if you are using, let's not say transformers, but like CNNs or just a bit larger models and dealing with images is already larger than tabular data often. They ask like, do I need to buy a 4080? Do I need to have a server, or can I just use GPU? Like basically, would you recommend, what would you recommend to someone that just have I don't know, a basic laptop and wants to practice data science?
Yeah, I absolutely understand your question, because I was there, my first year on Kaggle, I was not working for Nvidia. I had very limited compute. So I was absolutely in the position you're talking about. And I did all my code was ran inside Kaggle notebooks. And then I used some free resources like Colab. And then at one point, I think I even rented some cloud from Google in this one intensive competition. But that was actually rare. So the majority of my time, I was using the Kaggle notebook. But I would say that things have certainly changed. 3 or 4 years ago, you can maybe squeak by. You could actually maybe even squeak by an NLP and computer vision, maybe, 3 or 4 years ago using the Kaggle notebook. But today, yeah. I mean, today, these competitions, Kaggle's going to give you out like 20 gigabytes of images. The models today, these huge, even the computer vision models are now turned into these huge transformers. To be competitive, you want to use the bigger model, you want to use bigger image size. So I would say it's very difficult to compete in computer vision and NLP without some access to a powerful GPU. Yeah. Kaggle provides some. They recently upped what they offer. They used to have one P100. They now offer notebooks with two T4s. That's certainly helpful. There's a lot of free resources. You can use Colab, and then you can also rent some cloud compute. But so if your goal is just kind of learn and to do decent results, then yeah, you can definitely get by with all the free stuff. But if your goal is to be winning top medals and to be competitive, certainly in computer vision and NLP, I think you need to get access. And it's not necessarily super expensive. You can just buy, a top of the line gaming GPU, I think, buy two of them, install it into your desktop at home. And yeah, it may only have, I forget nowadays if it's up to 8 gigabytes of RAM or 12. It's a little bit on the low side, but you can actually kind of make that work if you're smart about it. You can put a few together and this and that. So when it comes to tabular data, sometimes there's some small tabular data comps and you can kind of get by with limited compute. But even some of the tabular data problems, as I had mentioned, especially Rexis, they get large. Even the data frame is now in the gigabytes. They're kind of workable. I think you can use. The simple answer to your question is you can definitely learn. You can definitely practice all this stuff using the compute provided at Kaggle, using some free online resources. You can even do decent in the competitions. But I think to be highly competitive, it certainly helps to, either rent, maybe rent a more powerful thing or build a little system at home.
You need to deal with very large models and very large data. So that's often, is it often more complicated than just having like a huge machine with a very expensive GPU, or do you sometimes need to do particular processes to make it work with multiple GPUs and everything like that?
Yeah, I see what you're saying. So I actually think, so I do often use multiple GPUs. One can actually get by if they have one very good GPU. So I'm actually, unfortunately, I'm not quite familiar with all like the latest model numbers, but I think some of the latest gaming GPUs now might already have 24 gigs of RAM or 48 or something. So I think some of the latest RTX that were just released are very powerful. And with just one of them, you can really do everything, because when you train a transformer, they've got these options where you can do gradient checkpointing, and you can do mixed precision. So there's a lot of these tricks, very small batch sizes. So there's actually a lot of tricks you can use to make it fit on a single GPU. Now, a single good GPU. I'm not saying a little teeny 5-year-old card, but if you have like a really good single GPU, maybe the best gaming one available today, you can kind of get by with one. But obviously, having more is helpful. You know, I have access to a bunch. I team up with people on Kaggle that do not work for Nvidia, and I often ask them what they have. And a common thing I hear is that, you know, a common Kaggler will have sort of 2 powerful gaming GPUs. Again, I forget the model numbers. Maybe they had 23080s, 23090s, or 24080s, but they kind of have 2. And you're right, it does help, because a lot of these frameworks will very easily use all the GPUs your computer has available. So that allows you to train the transformers twice as fast. When you're processing tabular data, you know, you can hold and you can do twice as much. So in conclusion, the frameworks kind of allow you to get by on one GPU, even with these transformer models. It is kind of on the verge of being difficult these days, but it is possible with using the tricks I mentioned. If you have maybe just a second one, then you're pretty much good to go in every scenario. And then if you have more, so, you know, as an NVIDIAN, I don't have unlimited, but I can get kind of more. I make requests, I can get more GPUs. Yeah. It becomes helpful for experimentation, because you want to train a transformer, but you have 3 experiments to do. So either you have to do experiment, wait for it to finish, and new experiment, or if you have 4 GPUs, you can maybe run 1 experiment on these 2 GPUs and 1 of this. So obviously, if you have more GPUs, you can put them to use to run more experiments. But you see how just a single experiment can actually get by on 1 or 2 GPUs.
Yeah, indeed. And my second to last question now is, basically, I assume I already know the answer, but you may be using something else. But my question, which I maybe should have asked earlier, is what is the tech stack that you're using and language you are coding? Like, what's your daily tools that you're using to do data science and to do Kaggle?
Yeah, so what I use with my data science work is Python. So and my favorite environment to work in is just a Jupyter notebook. So I love to work because I'm very much, I like to write a little bit of code and see the results. I write a little code. Jupyter Notebook's wonderful because you can immediately make some displays, see how things going. Once I have my pipeline stuff written, a lot of times I'll just export it as a pure Python file and just run the script. But definitely love Python. And then, you know, then within Python, obviously I use all the popular libraries. I mentioned earlier how specifically, you know, one I have found most useful is the Rapids framework from Nvidia, which the cuDF is great for data frames, and they have a cuML for doing machine learning models. There's many others, but those are the 2 biggest I use there.
Is there anything that we can learn more either from you, Rapids, or just Nvidia in general that is coming soon?
Yeah, well, your timing is great for that question, because we have our global technologies. Nvidia's global technology conference is coming up. It's March 20th to 23rd, and at that conference, we're going to be giving. So my coworkers and I, we're giving the Kaggle Grandmaster of Nvidia. We're giving a talk on how to build, you know, accurate models quickly and how to develop models quickly, and then we're also putting on a workshop, a little training DLI lab, where it'll be a 2-hour thing. Both of these are free with the free registration. And then at this workshop, we'll be teaching people in tabular data competitions how to do feature engineering using Rapids cuDF, and then how to accelerate their model training using Rapids cuML.
Oh, that's super cool. So is it accessible to someone that has no idea what Kaggle is and is just getting started? Is it like at a beginner level?
Yeah. I mean, if you go to the GTC and you search, so you actually, if you just search for my last name, if you just go to the GTC's website, say search sessions, put in my last name, you'll see the 2 talks I just described. It'll describe them. It'll mention the prerequisites. But so as I said, one's a talk. Obviously, the talk, you just come to the talk, and it'll make sense to anybody, and it'll be talking all about data. It'll be talking all about how to develop models and what's important and stuff like that. And then for the workshop, again, if you follow the description, it'll mention some prerequisites. And I would say, so everybody, if someone's interested in this, they should sign up, because that one has a limited attendance, because when you join for those 2 hours, you'll actually be given access to a cloud Jupyter notebook. So during the workshop, you'll actually be able to type in the code and follow along with us. And therefore, a requirement or a prerequisite is sort of just having the basics, just knowing how to use Python. And that's kind of it, I think. You should read the full thing. But basically, just having the basic understanding of programming, Python, and what have you. Because we're going to walk you through how to load in rapids, how to load in the data frame, and how to engineer some features. And then we'll walk you through building models.
Yeah, perfect. And the links are below for the people listening.
Oh, okay, cool.
And so, yeah, thank you very much for your time and all the insights. I personally learned a lot about Kaggle, which I only did one competition in my life, so I'm not that familiar with Kaggle, and it was super cool, super nice to learn about this. And also I'm even more convinced that it is a great tool to just learn, practice, and even find a job as you did. So thank you very much for this interview.
Oh, thanks, Louis. Well, thanks for inviting me on the show. I enjoyed talking with you also.